So this is ELC 131, Circuit Analysis 1, and the topic is the analysis of a parallel circuit. Now we see on the board I've provided the formulas that we will use in the analysis of parallel circuits. And the first formula states that Vs equals VR1 equals VR2 equals VR3. And this formula is derived from Kirchhoff's voltage law, which states that around any closed loop, the sum of the potential differences has to be zero. So we can see that Vs and VR1 are equal. And around this closed loop, we know that the sum of the potential differences has to add up to zero. So VR2 and VR1 have to be equal, which of course is also equal to V source. Now, the second equation states that the source current, or the total current, is the sum of the currents in this circuit. So we've got some current leaving the source and flowing in this direction. And when that current gets to this node, it splits into two currents. One current goes through resistor R1. The other current goes through resistor R2. Now these two currents, IR1 and IR2, are referred to as branch currents, kind of like the sap that flows through the trunk of a tree goes out into the branches, which always makes me think about in the third grade school play when I was enlisted to play the part of a tree. And I really felt like there should be some artistic interpretation. So in the middle of the scene, I acted like I was in a windstorm. And Mrs. Baker, my teacher, wasn't quite as impressed with the artistic interpretation as I was. But we got off track a little bit. Now, there's two formulas we can use to calculate the total resistance of a parallel circuit. The top one can be used only with two resistors in parallel. We refer to this as the product over sum formula. As you can see, it's the product of R1 times R2 over the sum of R1 and R2. And this equation can be used to calculate the total resistance of any number of parallel resistors. And we refer to this formula as the reciprocal formula, because it's the reciprocal of the sum of the reciprocals of the individual resistances. And of course, our last formula here is simply the conservation of energy, stated as an equation which says that the source power, or the total power, is the sum of the individual power dissipations. So let's analyze the circuit. And the first thing we'll do is calculate each of the branch currents. IR1 equals Vs over R1. 12 volts over 100 ohms gives us how much? 120 milliamps. And IR2 equals Vs over R2. 12 volts over 200 ohms equals 60 milliamps. Now that we've found the two branch currents, we can find the source current, or the total current, which equals the sum of the the sum of the two branch currents. So that equals 120 milliamps plus 60 milliamps equals 180 milliamps. Now that we know the source current, the total current, we can find the total resistance as seen by this 12-volt source using Ohm's law. Which gives us a total resistance of 66.7 ohms. Now, it's kind of important at this point to understand that this 12-volt source can't tell the difference between this original circuit, 100 ohms in parallel with 200 ohms, and this equivalent circuit with 12 volts connected directly to a single resistance of 66.7 ohms, because either circuit will force or cause the source to deliver 180 milliamps of current. Now let's look at the two equations that we have for calculating total resistance, and let's verify that they indeed work. And the first equation, of course, states that R total equals R1 times R2 divided by R1 plus R2. And if we plug these numbers into our calculator, we will indeed come out with a total resistance of 66.7 ohms. Now, when you enter this into your calculator, be sure and put the bottom of the fraction inside parentheses, or you'll end up with, of course, the wrong answer. Now, the second equation, the reciprocal formula, can also be used for this circuit, which says that R total equals 1 over R1 plus 1 over R2, which would equal 1 over 100 ohms plus 1 over 200 ohms. Again, let's put some parentheses here, which again will give us 66.7 ohms. Now, when you enter this into your calculator, you can, of course, type this in as 1 divided by, parenthesis, 1 divided by 100 plus 1 divided by 200, or you can make use of the x to the negative first key that's on your calculator. Your calculator may also have a key that simply shows you 1 over x. Either way. But for the analysis of our parallel circuits, again, we start by stating that all the voltages are equal. This is from the definition of parallel connected components. And that the source current is the sum of the individual branch currents. And we can calculate the total resistance either using Ohm's law and the source current, or either the product over sum or the reciprocal formula to find the total resistance.